Physics often begins with space as a smooth, continuous backdrop. In unified dynamics, that continuity dissolves into a discrete network of interconnected tetrahedra. Standard models typically treat the space-time grid as a fixed stage, calculating how particles move across it without defining the origin of the stage itself. Unified dynamics investigates a deeper layer, starting before geometry or dimensions manifest. It identifies the relational primitives required for a stable reality to exist. In this framework, geometry and gravity are outputs of a system, the physical consequences of an underlying operator grammar. The 13-layer theory stack provides the map. We start at layer 0, where basic relational rules build the structures we observe. Understanding the universe requires analyzing the discrete packet network that dictates its large-scale behavior. Layer 0 begins with a single point of location, a locus. Distinguishing one point from another creates a connection, a transport link between them. A third point introduces a cycle, establishing the first state of geometric coherence in a two-dimensional triangle. When the density of the system increases, it escapes the flat plane. A fourth point connects to the others, forming a rigid three-dimensional tetrahedron, the K4 complete graph. 5 specific variables now define the state of the structure: burden density, transport phase, closure, framing, and boundary integrity. At this fundamental scale, physical interaction consists of routing information packets across the edges of this tetrahedral network. The connectivity of the tetrahedron defines the dimensionality and volume of the local environment. Layer 2 introduces the requirement of closure. This is achieved when a sequence of packet routing completes a stable, unbroken cycle. To maintain this closure while handling more information, the system stables through an iterated function system. The IFS recursively copies and nests the tetrahedron within itself, generating a dense, self-similar fractal lattice. This scaling reveals a constant ratio between the structural overlap, delta, and the total state space dimension, n. The result is exactly 7/192. This ratio, x, provides the baseline for the system's primary constants. For example, the fine structure constant emerges from this geometry as 7/960. The scale of the observable universe is determined by the specific geometric overlap of these tetrahedra. At layer 4, the sequence of transport across the lattice becomes critical. These paths do not commute. Traveling path A, then B, leads to a different final state than traveling path B, then A. This lack of commutation generates a mathematical interference pattern across the lattice nodes. This interference accounts for the emergence of the Born rule, establishing the probabilistic nature of quantum mechanics as a mechanical result of discrete transport. Quantum uncertainty directly emerges from the complex interference of these non-commuting transport paths within the underlying network. In layer 5, quantum interference patterns organize into a macroscopic metric tensor, which we perceive as smooth space. Gravity is the accumulation of stress where local geometric loops fail to achieve perfect closure. In layers 6 and 7, matter appears as a persistent defect trapped within the tetrahedral network. To resolve the stress of these defects, the network evolves toward a balanced double pyramid octahedron. The vertices continue to expand, wrapping into a spherical icosahedron shell that encloses the internal defect structures. The rotational symmetries of this evolving network generate the gauge symmetries of the standard model, SU3, SU2, and U1. Particles and forces represent different sector realizations of this resolving geometric stress. At layer 9, atomic closure and chemical bonds are determined by the transport costs within these geometric shells. Scaling outward to layers 10 and 11, these local rules begin to dictate the expansion of the cosmos. The final geometric progression occurs as the icosahedron recurses into a 4-dimensional shell known as the 600 cell. Layer 12 applies these microscopic lattice rules to macroscopic cosmic observables. As the system recurses, it retains a specific fraction of its coherence at each level, 185/192. This retention factor determines the spectral index of the cosmic microwave background, matching satellite data. The theory demonstrates that large-scale cosmic structures can be derived from the fundamental properties of a tetrahedral lattice. We have traced an ascent from a single point to the formation of a tetrahedron, through its fractal scaling and into the emergence of quantum mechanics and cosmic structure. Unlike models that rely on dozens of tuned parameters, this framework operates without free variables. This master equation governs the system. Every observable is a combination of the bare structural spine and small native accommodations from the lattice. The system requires no manual adjustment. The results are mathematical necessities of the geometry. Reality functions as a single grammar, operating at every scale to build the universe.